Unit 4.2. Let's go ahead and jump right in. So first, let's find the introduction to computer science and find the source. Let's make a package. We're going to call it Unit 4. All lowercase, no space, finish. We're going to make a class in this unit. So I'm going to hit the class and it's called Unit 4. I want the main method and I'm going to hit finish. Then I'm going to line things up nicely like I usually do. Get rid of the stub. Alright, so what we want to do now is we want to talk about the Boolean logic that we saw in 4.1. This Boolean logic, we're going to use the logical operators and not the bitwise one. Remember, the bitwise one was 1, but the logic is 2. So we have this ampersand, and this is on the number 7. It's the key above, so you got to click the shift and 7. The OR is on the right side just beneath the delete key. You have to hold the shift and hit that button as well as the button right beneath with that line coming down. And not is on the 1 key. You have to hold the shift and click the 1. So that's the and, the or, and the not. In code, if we're writing code, this is how they look. So more importantly, Boolean logic occurs inside of the control structures. Now, control structures are the way to control your code, to write elegant code and purposeful code based on some conditions or repetition or step-by-step, line-by-line. Therefore, we're going to get algorithms out of this. So first of all, there are three types of control structures: sequential, selection, repetition. Step-by-step, conditional, loops. Okay, anything that repeats. So the first one, we did this already. Okay, the last quiz, what we had was sequential. Walk through this step by step. Don't miss a step. Selection is all about a condition. So if this is true, let me pause right there. If this is true, do this. Run this method. Okay, so you realize I said true. Boolean logic. So we're going to need some Boolean logic to do these selections. Repetition also has a Boolean logic tied to it. So while this is true, keep doing this, right? So this is going to be doing this more than once. So there's a selection down here as well, in the sense that there is something that makes this continue, a condition. And so now what happens here is when we write algorithm, the if statement, this if and if else and stuff, we're going to use this in conjunction with this, in conjunction with that, to write algorithms as we go forward. Okay, that's just the overview. In Unit 4, we'll pay very close attention to the if and the else if only. Okay, and then we'll take care of the others a little later. So the first thing I want to do is I want to actually go ahead and write a little bit of code to talk about the Boolean logic stuff. Okay, now I'm going to do the Boolean logic, and then the unit that follows, I'll touch a little bit of De Morgan's laws, and we'll look at that a little bit more in depth and work through some of those Boolean logic. So first of all, if you're writing Boolean, you can create a variable that's a Boolean. Realize it turns red. That's a special word. It's a special type. So I'm going to call this B. Now let me make this false. Okay. So I'm declaring a Boolean variable. I'm assigning it the value of false. Okay. Now you can't. Now even though we saw in 4.1 it could be 0. Not all languages allow this. Only some do. So in Java you have to use the word false. And of course false means the bit is 0. So I could go ahead and print this system dot out. I print B, and I'm gonna run it. Okay, I'm gonna just run this, and you're gonna see false. Okay, so let's do a couple of things here. First of all, let's try to look at the not first. I put a little line down, print ln, so we're going to a new line. What about if I print not B, right? Not B. What would that give us? Let's run that. True. See? Not flips the bit from false to true, or from true to false. The other one that I want to try out is what if I actually change B? I could do that. I could say, well, B is now true. And what if I go ahead and print B? After making that change, it should print it's true. See, look at that. It's going to give me false for the first one, true because I was a not B, and now it's true because B is true. What about if I do not B now? How about if I do not B? Okay, how would that work? Let's tighten this up a little. Let's see how that works. Well, obviously now it's false, right? Because not true is false. See, that was the not. That was the not. Let's check out the and. How about if I make another Boolean variable and call it C? And let's make this true. Okay. What if I print now? Let me use a little bit of copying and pasting. What if I print B and C? Yeah, this way it gets a little tricky now. We got to pay attention. So B is now true. C is also true. True and true from the truth table says it's supposed to be true. Let's run that. And voila, it's true. Last statement here is the B and C. What if I say, let's check out the B or C? And remember where the or is. If I want to change this to an or, I'm going to go on to the delete key, hold the shift and press that twice. No space, okay? If you put a space, you're going to get an error. Okay? Once you're dealing with Boolean logic, you got to be nice and tight, no space. All right, so B or C. Well, both B and C are true, and only one has to be true for the or to be true, so guess what we're going to get? True. Both the and the or are true. What if I make C false? Keep in mind that B is now true. It was false, changed to true. Now C is false. So let's look at this. It's saying true and false. Remember what the and says. Any of them turn out to be false, the whole thing becomes false. And for the or, only one has to be true. So this should get us a false and a true. Let's run it. False, true. That's the and, the or. Okay? We have the not as well. This B and C that we have here, sometimes you get the idea of the Boolean by the B and the C, but B and C are normally statements. Okay? So let me come down here and let's make some statements. Okay? Because sometimes it's just not good to just write B or C. So I'm going to say 10 is greater than 9. That's B. And C is going to be 3 is less than 5. Okay? So now these two are actual statements. And they could be true or false. So is 10 greater than 9? B is now true. Is 3 less than 5? C is now true. If I go ahead and print the and the or again, they should both get me true. Let's look at the last two. See, trues. True and true. Now what if I change this to a 6? Okay? Now B is true, but C is false. So the and should get me false. The or should get me true. Let's run that. See? False for the and, true for the or. Now, let's go ahead and change this to say 10 is greater than 10. These are now both false. So what should I get for the last two? False. See? Both false. Now you're looking at this and you may say, well, okay, this is nice and good and everything, and I kind of get what's going on. But what happens here is that these things are not going to be written exactly like this in code. Okay, so let's go a little deeper. And let's make a variable. So let's say x is 8 and y is 10. Now I can see if I write some Boolean statement. Let's say b is x is greater than y. See? Now that we have variables, that's what's going to happen. We need the variables to do things, to figure out values, and they're going to change during the app and things are running. And at any particular time during the app, X could be greater than Y, it could be less than Y, so things could be changing. We want to keep track of that. What about C being Y is greater than X? We're looking at this right now. X is less than Y happens to make B true. Y is greater than X happens to also make a C true. So if I go ahead and print these ands and ors again, this should get me both true. Oops! I got a false. I'm thinking that these things should be true, and I had a false. So let's see. X is greater than Y, and I just said less than. See? Made an error. Messed up my app. See? It's greater than. So 8 is greater than 10? No, not true. So this is false. Now if I put a less than here, see, in my mind I thought I had a less than, but it was a greater than, and my code is showing me, hey, you were off, your bit's off, your logic's off. Oh, by the way, logic error is what's going to be big now, because now that we're starting to write control structures and we're dealing with Boolean and doing Boolean logic, there's going to be a lot of logic errors, and we got to be real careful here. See, I just made one. I called this less than, but I actually wrote greater than, and as easy as that, I made a mistake. So run it now, they're both true. Thing right now is that this and or, we're going to use this a lot. So we're going to have two statements, and we're going to kind of combine them. But we're going to have more sometimes too. We could have another one. We could do and C. You know, it doesn't have to be two. But let's see. There are some other things sometimes we want to check out. One of the things we want to check out, not just and or, but equal to. Okay? Two equals, no space. Remember? See that error? No space. Just right next to each other. This is asking, is the B value the same as the C value? They're not. Okay? Or they might be. Let's see. Let's run it. It said it's true. But let's see what happens here. So X is less than 10. Okay? And X being 8. That's true. That makes B true. 10 is greater than 8. That makes C true. So B is true. C is true. They're definitely equal. Okay? Alright. Let's put not equal. Okay? No space. Remember, no space. No space. If I run this now, should be false because they are equal. What if I change it back to what I thought what I had it as before when I thought it was less than, right? I put greater than. So what about that? So let's run that, see what we get. Well, the first one here is false. Let's see how that works. Well, B, 8 is not greater than 10. So B is false. So false is equal to true? That's false. See, it's getting a little tricky there. Is false equal to true? No, that's false. Even though we're working with false and true, the answer is still false or true. Now we have, is these things not equal? The answer is yes, because false is not equal to true. Okay, let that one sink in there. So when we work with Boolean logic errors could creep in if you don't pay close attention. Let's go with the greater than or equal to. Okay, let's go with greater than or equal to. And let's make the 8 a 10. Now, Y, which is 10, is not greater than 10. So C is false. X 10 greater than or equal to 10? Yes, that's true. So let's run that. So what we get? We get a false and we get a true. Let's see how that works. Are they equal? No. One is true and one is false. Are they not equal? Yes. One is true and one is false. So we have greater than, equal to. We have less than or equal to. Like if I do this. Remember, the less than has to come first before the equal to. The equal to is always last. So whether it's not equal to or equal to or less than equal to, greater than equal to, greater than equal to, less than equal to, those greater than, less than, not, they come first. Then the equal comes after, and the equal is right next to it. Okay, so let's run this. What we got? It says one is true, the other is false. That's the last two statements. Okay, so they are equal. Let's see if it's true. That's greater than, this is less than equal to, yep, this is true. And is that not equal? No, they are equal. So they're saying that they're not equal is false. So you see, it gets a little tricky there. That's all we need to look at for now for Boolean. Again, let's make a little recap here. Boolean logic. We need ands and ors and nots. They're all wrapped up into control structures, which we will see later. Here are some examples. We looked at how the Boolean could be printed, how the nots and ands and ors and greater than and less than and equal to can be used to evaluate, to make decisions in our code. We're going to introduce these control structures along with this Boolean logic. Next section, though, we'll look a little deeper into De Morgan's laws, which is a little bit more logic with these Boolean variables. That brings us to the end of 4.2.